Good evening, everyone. So this is the final session, but hopefully the most interesting this afternoon. So we're going to be talking about or discussing kind of what happens when GenAI scales and and how you guys here tackle some of the challenges that come up, right, as we try to move GenAI systems from a proof of concept to large-scale deployment. Okay, we've all heard about seen the magic of a working proof of concept system that works perfectly well in the lab, right? And then you try to move this into real world deployment and things begin to break. So performance, latency, reliability, right? And then all kinds of issues begin to come up, right? I'd like to hear from each of you because I know you guys have had to deal with real-world experiences or challenges like this, right? And also it would be good to give me some context on your experience and how you've dealt with, and what's the first thing that challenge you've met when you've tried to move infrastructure or GenAI from proof of concept to real-world deployment?
Yeah, no, excellent question, EJ. So hi, everyone, I'm Shashank. As you mentioned, there are 10 different things that could break when you try to deploy some things in production right out of POC. One thing that I have dealt with quite often, and I continue to do so, is latency. I think when we are working on POC, our essential focus is on the correctness. How correct our POC solution is. You present to the stakeholder, you get a buy-in, and when do we go to live? We were supposed to go live yesterday. And so the path from going from POC into production is usually very rushed. And when we start to see things to fail, it comes back to the root question, which is we were trying to optimize on only correctness. And that's a half question. The complete question that over the time we have come to realize is you need to be asking what is correctness in all different scenarios that you're going to encounter. And latency is one of the things you will start to see getting hit pretty much if your solution is not something that you have designed it to scale. And I don't mean to suggest an average latency. I think as you start to see your P50 and P99, that's where things starts to fall apart. Your P50 can be absolutely fine and you could sleep like a baby in the night. But when you start to see P99, that's where the real fire is. And oftentimes, as you dig a little deeper into it, it's not so much about your model itself. Your model works. It's usually everything around your model, be that the orchestration layer, be that the chaining that you have, be that the serving infrastructure. So I think to allow others to speak on their experience as well to summarize things. I think when you're trying to go from POC into a scalable production solution, the real question is, am I optimizing on correctness in isolation, or am I trying to take into account everything that we are going to hit when we go live?
What's P50?
It's the overall latency at kind of different P50, P99. So basically, what's the probability of correctness or 99 percentile or 50 percentile?
Got it. Mm-hmm. All right. Hi, everyone. David Hefter at BlackRock. We're a large asset manager. I focus on our AI strategy. In terms of production grade, I would say accuracy hallucinations are definitely a hot topic. We've come a long way as an industry for AI, where before reasoning models, where you just had next token prediction, hallucinations were quite common, but reasoning models have helped quite a bit to have AI check its own work and pull from different sources. So it's less of a problem. We do look at not just overall accuracy, but accuracy compared to humans, because humans aren't perfect either. So if you're augmenting or replacing human work, you want to compare to how the humans are doing. In financial services, you have that can be the case. So what else? Let's see. On the accuracy side, it depends on the use case. A lot of investing is about doing research. And in a similar vein, we rely on AI for research now. unlike before, but we still rely on our own research and others. And just like you can't trust necessarily what some pundit out there is saying, you have to do your own due diligence, verify sources, use critical thinking. It's the same when AI comes into play. So I think all of that contributes to it. And then at the same time, you got to kind of just put it out there and use it and see how it goes. So there's a little bit more of a blurred line between POC and production, I would say. And I would call it the testing phase, where you could define testing as early adoption of using it. And then when it cuts over and you're using it in production, it just means really you're relying on it more than you were earlier. So all of this factors into our governance approach, but it's an interesting new dynamic we're dealing with, and I think it'll just get easier over time because we'll all get used to it. It's just so new right now.
Yeah, that's a good good answer. Hi, everyone. My name is Maher, Senior VP of Engineering at Betterworks. I lead engineering teams and AI teams, and this is my third time speaking here, and this is the third time I'm asked what breaks when we move from proof of concepts to production. And the honest answer is everything. If this is your first AI project, everything will break, and that's the reality. Why? It's because you don't have the right systems in place, you don't have the right observability in place, you don't know exactly all the things that are happening in the system. And AI is quite more complex than regular distributed systems that we had years and years of experience working with. And I'm talking about businesses that are adding AI to their stack. I'm not talking about like pure machine learning and AI engineers and teams that are very familiar with the concepts here. So if you are a business who is adding AI, everything will break. But to go into something more tangible for all of you, I would say your assumptions will break, like things that you thought how AI will work and how your users will behave with AI, will use AI. I think these assumptions, most of them will break and will be wrong, and you will have to kind of adapt and go back and redesign. And then the second thing is more the reliability of the system. Because as an engineering leader, I see all of these red signals coming from all over the place. It could be latency, it could be throughput, it could be memory, it could be GPU usage, it could be anything. So for me, I really freak out when I think my system is not reliable. Well, with all of this being said, it's not very hard to iterate over this and optimize, and then have less and less things breaking over time as you build up more maturity with the stack, more understanding of how things work, and especially more observability. If you're collecting the right metrics and the right data points, now you'll have less and less things breaking.
Okay, thank you very much, Maher. Let me turn to you and just follow up with that. I know you've led engineering teams in SaaS and gaming for over 2 decades. Okay, how do you guide your team across the AI decision framework, right, to say make a choice between picking a more expensive LLM versus a cheaper SLM, right? How do you think about that choice and trade-off?
Yeah, that's a good question. And again, I would really focus on that perspective from engineering teams or business leaders who didn't have necessarily AI background and AI stacks in their tools. So they're just going and trying to build features that meet users' expectations in this space. So the AI decision framework I came up with is based on 3 things. The first one is the what. What are we building and why we're building this? So understanding the product, the use cases, and so on. And then the how is where it comes more to me and my teams on designing. Are we going with like off-the-shelf solutions for AI? Are we self-hosting? I work in HR tech, and self-hosting has been the way to go because our customers don't want to see their data go into other sub-processors, and they want everything to be on our systems. So going with open source solutions, deploy them on our own cloud, and then manage it, our GPU cluster and all of that was something we had to deal with from a how perspective. And then the last level of the AI decision framework is the reality. And this is where, again, things break, and this is where, your design, your thinking is facing the real usage. And that's where you need to adapt very quickly. So alongside the AI decision framework, which is the what, the how, the reality, we use a framework for like a flywheel framework where you go and plan for what you want to build. You build it and then run it. And then that's maybe half of the process. The most important part and the bigger part of this flywheel is optimizing. having capacity in your team and your resources to go and review in a very short manner, to redesign, to upscale systems, to really think about latency and prioritize it, or your focus will go towards more cost, because cost could break, by the way, and try to optimize for cost. So it's more about being aware, even if like with the pace of innovation today, we could be very quickly overwhelmed. So as a leader, business or engineering leader, you need to be aware of what are the options to help your team and guide them towards better and better solutions over time, but don't expect perfection or perfect solutions from day one. Things will break, and that's why we're here as leaders, but also as a team of software engineers or AI engineers to get, optimize and go back into the flywheel again and build better and better software over time.
Cool. Thank you very much, Maher. Let me turn over to you, Shashank. In your kind of experience, as you deal with large-scale infrastructure that could potentially churn out large demand spikes, right? How do you work to maintain low latency, right? And still ensure that you can maintain low cost and not allow costs to actually spike, right? What kind of things do you guys do at Walmart, for instance, to deal with this? Are there specific techniques, right, that you use?
Yeah, again, I think another great question. We want everything to be high quality at as much of a low cost as we want, and we just try to find some good balance and trade-offs there. But what really I see that to be as a core tension when it comes to production AI. I think, and when it starts to fail, especially if your demand is spiking at any given point of time in year, the very instinctive behavior to that is let's throw in more compute, let's have more replicas and try to resolve that as a stopgap solution. But then you have finance over your shoulders, like why our costs are $300K this month, and you're spending hours justifying on that. I think a smarter way to think about it is not to consider your model as a monolith, meaning there is no one correct model universally that you want to be using it for your system. Now, there are 10 different ways. I think engineers across different organizations are trying to approach this in their own different ways. And they all comes with their own pros and cons. But one thing that I have found to deliver, if you were to believe in 80-20, is to start thinking about something of a routing layer in your overall system design. And what I mean by that is not all of your tokens needs to go through the best model that you have. Some tokens can be routed to a very lightweight model, and some tokens can be reserved for the best model. And the best here I really mean by that is a model with billions and trillions of parameters. So by doing that, what you're really doing is that, and especially when you look at it from a production standpoint, again, 80% of your traffic is going to be somewhat similar in pattern. So you can also leverage caching when it comes to that, if not just a small model. And you can reserve the higher kind of parameter model for your tail queries that you're expecting. And what this really gives you is benefit in two forms. So not only latency, because if you're using a small sized model, your latency is going to be low, but also your serving infrastructure is not as much demanding as a large model could be. And then if you layer in with a right amount of caching, then you have even higher kind of savings from a latency overall standpoint, because you're not even hitting the model to begin with. I think so. Taking a step back here, I think how you want to think about your system or interactions with LLMs is not in a way where you're dealing with a monolith system, but trying to really understand what patterns that you have with the queries that you are getting and what can be the right tool. Again, routing is one way to tackle that. Caching is another way. If you're having similar kind of queries being asked to your LLMs, you can have a classification that can classify, okay, how much similarity is between two queries that you have been receiving, and can those be served with the right amount of caching. Another area that also has been explored quite a bit lately is a token pruning side of things. So as we start to think about it, the real latency is not just about model predicting, but how much it needs to input, right? At the end of the day, you are putting some number of tokens into the model, and you're getting number of tokens out of models. So how do you minimize the amount of tokens that are going in and perhaps minimize the number of tokens that are coming out? So again, as you start to think about some of those approaches, you will at some point plateau in terms of benefit that you are getting. But these are all different tools in your arsenal that I think engineers would try to explore and get the best benefit out, just to make sure that, one, your latencies and throughputs are met. Because end of the day, if millions and billions of users are using your systems, no matter what the cost is, you want to make sure that the lights are on. And at the same time, the secondary goal, and in some cases primary goal, is to make sure that you are cost effective as well.
Thank you very much, Shashank. So let me turn over to you, David. So at BlackRock, right, I mean, unlike Maher and Shashank, right, where you have to deal with sensitive financial data, right? And with that kind of data, sometimes just close enough won't cut it, right? Your retrieval layers runs into millions of financial data. How do you maintain kind of your system and not allow it to become brittle, right? And get as high as accuracy level as you need to for your use case?
Yeah, I mean, I think we're entering an age of optimization, and it's for token and cost sake, but also for accuracy sake. And there's all sorts of companies popping up, I feel like, trying to solve for optimization, just like we've had in the past with cloud computing and search engine and whatnot. But to talk about that, so I mean, we do all sorts of like agentic RAG type solutions. We do have tons of content, both 3 layers of like truly publicly available, more like call it vendor provided, and then our own internal content. And we're diligent about citations. That's like a no-brainer, table stakes sort of thing. And then we spend a lot of time really tuning in on what's noise and what's real insight. And so we'll incorporate that in some ways as a fine-tuning data set to have our own model usage do a better job of pulling the information that's really relevant. So that's one thing. And the other, I guess, major thing is we evolve how we operate, like the culture of our investment teams, to ensure that we are capturing the relevant notes in the relevant places, so that way the data can then be leveraged by AI. By notes, I mean like you're going to a meeting with company management, say some public company, talking to the CFO. Earlier today, I was up in Palo Alto at the Citi AI Summit, and we were doing just that. So that type of information, we want to be diligent about capturing it, but doing it in a way as well that can be AI ready. So I think these are just a few things that we're doing. I think it'll evolve much more so. We also pull information from our group chats and our emails and all that good stuff too. So meeting notes, we're constantly feeding the beast with data, and we want to make sure it's all AI ready.
Okay, thank you very much. And Maher, back to you. I know you've talked in the past about the trust gap in engineering, right? And the whole idea is as you scale GenAI, right, it's not just the infrastructure that can break, right? But trust in the data output can also break, okay? As a leader, right, where in scaling large-scale systems, how do you ensure that as you do this, right, you maintain high reliability and high trust, right, as you do this?
Yeah, that's a good question, because the way I think about optimizing all of these kind of metrics and KPIs, latency, throughput, we have also some other metrics around quality of the outputs, safeguards and guardrails that will also prevent us from ingesting the wrong kind of data or the undesirable inputs, and also not generate an undesirable and desired output. So for me, all of these metrics are kind of competing against each other. And the hardest part of my job is to find that kind of sweet spot where I make it work through latency, throughput, cost, performance, and quality for a specific use case. So I think the focus will be on, as Shashank was saying, not every use case is the same. Some use cases require high level of quality and kind of safeguards and guardrails running to ensure everything is top notch on that side. Some others focus more on latency. So for me, what we need to do is definitely understanding all of these different scenarios and use cases, and then go and build these guardrails and systems. So as an example, at Betterworks, we have a bunch of guardrails that we run to make sure all of the AI operations, input and output, are going through this. We are an HR tech, and it's very important for us to build responsible AI. I'm very sure you're all familiar with this word now, that is based on transparency, accountability, explainability as well. So everything we do, it's not just pure AI operations, input, output. We have so many round trips with AI and conversation with AI just to make sure that the input is safe, the output is safe. And also, it's not just about safety, it's about accuracy and bringing value to the end user. So by doing these extra steps, we impact the latency, and the latency will have to go down. And now, looking back at that, we go into this flywheel again to optimize. How can we optimize latency again while having our bar for quality and accuracy and safety and responsible AI high? And that's the exercise we go into next. So it's a push and pull game where every time you have, for very specific use cases, more requirements on some of these metrics compared to others. And it's the successful team is the one that can figure this out as soon as possible, going through different iterations. It's not going to happen in the first one, so you need to go and operate and understand. And then also learn from the usage, because the usage of the app will guide you. So that's why it's very important to have some sort of feedback loop from your usage, where your users could be able to say, this worked or this didn't work for me, or provide more specific. So you can go and either fine-tune the system or improve your prompts and your agentic AI for the next time the same use case is needed.
Cool. Well, thank you very much, Maher. I think that's about all the questions I have. Do you guys have any questions for this panel?
We are the last session, so we have all the time for questions.
You can take as much as time you like to answer my question. As GenAI scales, which constraint breaks first, right? In production, latency, cost, or reliability. How does that fundamentally change your product or business strategy? How have you aligned with your peers on that?
Who wants to answer that?
Thank you.
I have some thoughts. David, you go first, and then I'll go.
I mean, as an institution, you're going on a journey, and so you start with the use cases that you can learn from and accommodate any sort of breaks or failures. So things that are informational only, that a human could be in the loop and just assess. That's step one, and then you kind of evolve from there to more autonomy, more being done behind the scenes. And so that's one way to kind of leg into it, and you kind of build up your own resilience and processing.
Yeah, for me, there are different parts to your question. I would say the first one is maybe purely technical. How would you address these? And the other one is more cross-department collaboration. Like, what do you do about this? I mean, I would start with the second one, because AI is not built by just engineers or machine learning, or AI partners. We work with product. We work with, we have a council cross department where people are involved to just help us design these AI features, including our customers. So especially in the B2B business, it's very important to do the research to understand the customer needs. So when something breaks, we need to really pinpoint if this is breaking because of technical kind of limitations, or it's breaking because of a use case limitation or a wrong assumption that is wrong. So we go and again, go into the flywheel and try to plan again and then build again and then run it and see if we need to optimize it. So that's us on a cross-department level. On the engineering level, when things start breaking, the first thing that breaks, again, I said this earlier, your trust in the whole infrastructure. And when that happens the first time you're running your AI systems, the first thing you do is you spin up more GPUs, I would say. Like, give it more resources so it runs. But when you do that, the next thing that will break is your cost. Your cost will go crazy, and then you look at this, and as you said, my co-panelist here said, your finance people will ping you and say, hey, why this is costing so much? So you try to go and optimize and understand if you can reduce or manage scaling of your GPUs in a dynamic way that can be cheaper, I would say. But one of the things I found as digging deeper into how the way AI works compared to previous systems is you can really upgrade your GPU to use more expensive GPUs while overall reducing the cost of your AI by using less number of GPUs. The beauty of GPUs and AI in this place is you can have the more expensive GPUs that can run higher throughput, serve your customers faster, and go in idle mode faster. So you don't need too many of these, you need less. So if it's twice more expensive than your previous GPU, but you need 40% the number of GPUs you had before, you'll be saving money, even if that GPU is more expensive. So again, it's about learning and being aware of the options versus just overthinking the whole thing or redesigning.
Thank you for an insightful discussion. I'm Deepthi, and I'm curious about how do you handle bias as GenAI scales? Bias in your data models, bias in your systems, as GenAI scales, does the bias scale? And if it does, how do you handle? Thank you.
You want to take that?
I can try to take on. I think a more fundamental question is defining bias in the first place. I think identifying a bias, there are 10 different ways and tools and techniques that are out there that can help you see and mitigate the bias. But what I have found in my own experience is that there are new biases that are being put out there in market, which quote unquote can be classified as a bias that needs to be alleviated. So I think when we think about bias, they also come in different forms in terms of what application and industry they are being, GenAI is being used in. Right, so I'll give an example. If you have an extremely highly personalized recommendation systems that are based on everything that you do in your life, be that your social presence, to your shopping behavior, to your interactions, and it then tries to recommend you something specific to you as opposed to something else to somebody else. One way to look at it is it's a highly personalized recommendation. The other way could be that there are some biases in what is being recommended to you versus the other person. But in the end, both the users ended up buying whatever was recommended to them, or took an action what was recommended to them. So now really the question here is the objective of the system that you are building. Are you achieving them? And if you are achieving those objectives, however you are defining the bias to be, can those be alleviated? And if you alleviate those biases, can those objectives still be achieved? So I think part of when you hit the reality of how some of the systems are being used, having a trustworthy AI going forward, how it shapes society and the solutions that we are building, trying to mitigate as much bias as we can. The practical side of it is that a lot of those innovation is also fueled by having an ROI, and ROI usually runs on objectives that you're trying to achieve.
I think this is a good question. So it's a challenging topic because bias will exist in the models, and so just a few ways to kind of tackle it. One is there's some guardrail options you could put in place to try to catch it. It's not perfect. Another option, when the use case allows, you want to just ground to some sort of source of truth information, so you're less reliant on the model's generated output, but more what it's the source that it's referring to and uncovering for you. And then there's like a fallback option. You always have a human in the loop, ideally, who can weigh in on their own judgment. On the flip side of that, humans have bias, of course, and so AI could be used as a tool to help capture human biases. We are an investment shop, so there's an element of bias that comes in from the investment process. And so AI can be used as like a sense check on any sort of decision being made there. So yeah, that's kind of how I think about it.